Okay, so good morning, not good afternoon, everyone. My name is Amanda. I'm from the Université de Sherbrooke, and this paper on climate change, intimate partner violence, and climate resilience initiatives is co-authored with James from the University of Florida and Nidia Menon from Brandeis University. So you're probably aware of the increased frequency and severity of extreme and unexpected weather events around the world. And there is now some kind of consensus in the literature that climate change is acting as a threat multiplier. It's especially for channels of agricultural income as well as intra-family dynamics, and these are intensifying the vulnerabilities for gender-based violence. So we know also in the literature that climate change impacts are not gender neutral. Women are disproportionately impacted in developing countries because of their extensive involvement in agriculture, existing political, social, and economic inequities, and gender-specific roles that are deeply rooted in cultural norms. So there is a need for an assessment of these gender-differentiated impacts of climate change, and also to understand how they manifest themselves. What are the precise mechanisms, in addition to the agricultural channel, of course, through which these impacts exist. So our focus in this paper is on Bangladesh. This is a country that, even though it's responsible for only 0.56% of global CO2 emissions, it ranks as the 7th most vulnerable country. It is very much impacted by all types of climate changes. And this is nearly 40% of the population directly employed in agriculture. Them extremely vulnerable, especially the coastal regions. And they estimate that the potential lost is going to be at least 1/3 of agricultural GDP by 2050. So we know that in some empirical studies already, we can see that climate change exacerbates existing gender inequalities. It's undermining hard-won achievements made in bridging gender gaps. And in Bangladesh, the incidence of IPV is quite alarming. According to an official report from the Bangladesh Bureau of Statistics, 73% of ever married women experience one or more forms of IPV. They report experience one or more forms of IPV at least once in their lifetime. And over 1/3 of men aged between 15 to 49 agree that wife beating is justified for several reasons. So we're actually linking these ideas in our motivation to understand what could be the impact of climate shocks on women's attitude towards IPV. And so we have two objectives in this paper. The first one is to quantify these effects. So we document the extent to which these effects diverge across existing environmental and socioeconomic vulnerabilities. And our second objective is to evaluate whether and to what extent climate resilience initiatives mitigate the negative impacts of shocks, of environmental shocks, more precisely. So we're here going to focus on the Bangladesh Climate Change Trust that was financing community-based projects that promote climate adaptation and resilience. And we aim at empirically evaluating the effectiveness of these BCCT projects at attenuating the harmful impacts of climate shocks on women's well-being. A quick preview of the results. We find, first of all, that the impact of the higher frequency of dry months is not significant for the average Bangladeshi women, but drought indeed increases the tolerance of intimate partner violence. And this increase in tolerance is, of course, strongly correlated with the actual experience of IPV for two groups of women, as expected for those living in agriculture-dependent communities and for those in the lowest wealth quintile. And the second set of results pertaining to mitigation, we find that proximity to a BCCT project neutralizes completely the effect of droughts in agricultural communities across all wealth strata. We also check the mitigative effects of other development assistance projects. We find significant but smaller attenuation effects. And when we turn to an analysis of the potential mechanisms through which these BCCT projects could be impacting well-being, we find some suggestive evidence here that access to media, transport facilities, electricity, and cash earnings could explain part of the results. Our contribution to the literature, we first of all speak to the line of the literature that considers the inequitable socioeconomic impact of climate change in developing nations, with important contributions by Banerjee and Mararaj, Deschênes and Greenstone, and more recently, Makonga in 2023. That literature has shown differentiated impacts on mortality, human capital, labor reallocation, and conflicts. But here we are contributing to the stream of the literature by documenting how climate change worsens gender inequalities, specifically for poor agriculture-dependent women. Our work also builds on existing literature on domestic violence, gender equality, and women's agency in the developing world more globally. Here are some important contributions by Abuena and Kolfers, Kools, Diaz, and Saldearega in 2023, amongst others. And the third line is the contribution lies to policy debates on mechanisms that mitigate climate impacts. And several studies in that stream of the literature have been assessing the mitigating impacts of employment generating programs, poverty reduction programs in India, for example. Others have considered the value of cash transfers in enhancing resilience, in reducing losses. And here we analyze empirically the effectiveness of climate aid funds, okay, that are being used specifically to address adaptation and resilience. So to achieve these aims, we construct a data set here. We are pulling from various sources. First of all, we use microdata from the Bangladesh Demographic and Health Surveys, 4 rounds from 2007 to 2017. We have a pool cross-sectional data set, and we use the geographic coordinates of each surveyed cluster across rounds to merge with the geocoded climate data. So we have variables related to attitude towards wife beating, the actual experience of IPV, and other proxies for other dimensions of women's status. And we use the 2007 wave, which is actually the only one that contains the domestic violence module to measure the experience of spousal violence. And here we obtain information on whether ever married women had ever experienced physical or sexual abuse committed by their husbands. We need meteorological data, so we are drawing from the Copernicus Climate Change Service, where we are able to obtain those indicators from 1980 to obtain gridded monthly data at a spatial resolution of 0.1 by 0.1. So there's quite fine resolution here. We have temperature, precipitation, vapor pressure, and so on. And we're going to focus on these variables to construct our measures of shocks, and then we're going to control for several other variables in all our regressions, and we match the latitude and longitude of each sample cluster over DHS rounds to the geocoded weather data. And to do so, we are using inverse distance matching to obtain those local measures of climate through gridded climatic observations. And since we need also additional data sets, we're pulling from various sources here that I've summarized. We have climate vulnerability indices, pre-treatment, geographic and socioeconomic covariates at the sub-district level. And to do the analysis on the mitigative effects of the Bangladesh Climate Change Trust, we digitized the list of approved and finalized projects from the official site on the Bangladesh National Portal. We also have information on the project name, the implementing agency, the projected cost, the starting dates, the end dates for most projects, because we need that information to do a proximity analysis. We have location data from the project title supplementary documents on the portal and from the Ministry of Environment, Forest and Climate Change. So in the end, we're able to pinpoint the sub-district location of 183 projects that spread across Bangladesh with varying start and ending dates from 2010 to 2020. So our empirical strategy, our baseline strategy, we are relating here the outcome of interest, which is a dummy variable that takes a value of 1 if the respondent agrees with at least one of the 5 statements pertaining to situation in which wife beating is justified. We have a measure of shock here, which is the cumulative number of months over the 3 years prior to the survey month in which the rainfall realization was at least 1 standard deviation below the historical monthly average. We have a vector of climatic conditions, including wet shocks as well, temperature shocks, and we allow temperature to vary non-parametrically in the month and year of the survey. But we also have controls for climate variables at the time of the survey. So the identifying equation here is that conditional on the controls for contemporaneous weather, location-specific seasonality, and other variables in the model, as guided by the literature, there are no omitted variables that are correlated with both the number of dry months, so our measure of shock here, and with women's attitudes towards IPV, and therefore weather shocks are as good as random in this case. So if you look at the main results, here we find, first of all, that droughts increase women's acceptance of IPV in the agriculture-dependent communities, as highlighted here, not for the full sample of women included in our data set, and across different wealth strata as well. So for the 3 lowest, 2 lowest, and lowest wealth quintile. As you can imagine, for this first set of results, we have several robustness checks there. We have alternative specifications. We address population sorting. We have additional controls. We look at the impact of monsoon, drought shocks, and growing degree days. We also try to make a first attempt at analyzing what could be the mitigative effects related to sectoral area of residence, literacy status, and economic prosperity. So basically, we look at the heterogeneous effects, again, for focusing on the lowest wealth quintile. And then we have the effects by decade of birth, that is heterogeneity by cohorts, where we augment this baseline regression with indicators for women's birth decades. And then we have separate interaction terms between the frequency of dry months and each birth cohort. And what we find here is that women's acceptability of IPV across all birth decades are impacted by dry shocks, but that these effects are relatively more pronounced for women born in later cohorts in the poorest households. And that could be related to the specific socioeconomic forces at work, the cultural norms, and also the intensity of these weather shocks over time. We also examine whether wealth and agriculture dependency compound each other when communities experience drought. We examine whether intra-family employment structure plays a role in shaping this relationship. So here we focus on employment, occupational status. So I can go over these results if you have questions pertaining to these 2 points. So we also, like I've said, look at the experience of IPV in addition to attitude towards wife beating. And here we find some evidence of the association between dry shocks and sexual violence, and both physical and sexual violence, even though the impact, as seen in column 4, is marginally significant. And then we use other agency indicators as well related to participation in decision making to see whether we find robust evidence on women empowerment as a whole. And the last part of the second part of the analysis is, sorry, I can't see. It's 5. Okay. Yeah. Thank you. So, this climate change trust is part of a larger policy that aims to build resilience against climate change in Bangladesh. So starting in the 2000s, the Bangladeshi government has been implementing several measures aimed directly at mitigating the effects of climate change. These measures were executed as a nationwide initiatives to strengthen resilience, diminish vulnerability, and bolster adaptation. So we're going to focus on evaluating the efficacy of climate funds assigned to projects across regions in Bangladesh, and we leverage the phased introduction of this initiative to evaluate its influence on the relationship between shocks and IPV. So we extend our strategy here. You see there's still the dependent variable Y for individual I in cluster C in district D, for survey month M and survey year T, related to the number of dry months 36 months before the survey date. And then we augment it with a dummy for the presence of a BCCT project. So this is equal to 1 when the respondents cluster falls within a sub-district that had at least one BCCT active project at the time of the DHS survey. And then the interaction between the dry shock and the presence of the shock conditional on the same set of spatial temporal fixed effects and vectors of controls. So the coefficient of interest here is pi, which is the additional effect of dry shocks for respondents in sub-districts with an active BCCT project. But we also look at the net effect of drought by looking at beta plus pi in our regression. And of course, there is always a threat to the internal validity here, some endogenous issues. So to account for potential selection effects, we follow the related literature and we leverage the location and time of which the BCCT projects are active. So we also control for whether there is an inactive project around. So this will be an indicator variable that is equal to 1 if a future BCCT project is planned in a particular sub-district but has not yet been implemented. And we also investigate treatment intensity by considering the number of both active and planned inactive projects. So to summarize the results here, as you can see, when we look at those mitigative effects, we still see in all columns here that dry shocks are impacting women's tolerance of IPV. But when you look at the coefficients for the interaction terms, the number of dry months times the BCCT project, we find strong evidence of mitigative effects here, even when we control for the presence of inactive projects, and even when we replace this measure for the presence of BCCT for the number of projects around the surveyed women in our sample. So additional robustness checks here. To conclude, we have a number of pre-CCT covariates at the district level. We include only those projects that were active at the time of the survey. We exclude projects that were introduced more recently, just in case they didn't have the time to yield effects. We also control for development assistance from other donors. So there is a lot going on here. For the potential mechanisms, like I've said in the introduction, we are looking at how these active BCCT projects play significant roles to impact women's well-being overall. And this increase in women's well-being near those project sites could be prompted by the upswing in economic activities caused by the specific projects. So to conclude, because I have maybe 1 minute left or less, so it's good. Okay, so this paper empirically documents how climate-induced weather shocks can generate detrimental social spillovers in vulnerable contexts. We find that an increase in the frequency of dry months leads to a sizable increase in tolerance of IPV among women and among poor women and women living in agriculture-dependent areas. But the implementation of BCCT projects in those communities relying extensively on agriculture eliminates the adverse impacts of dry shocks. And taken together, our research contributes to the literature by providing a comprehensive assessment of climate change and women's agency in Bangladesh. Thank you.
Okay, so I just have some brief comments on the paper, some suggestions. I think this is a really wonderful setting to study this question in Bangladesh, both because climate risk and climate change is incredibly salient in Bangladesh, but it's also a setting in which there's relatively high incidence of intimate partner violence. And kind of beyond the scope of the paper, Bangladesh is also a really interesting setting to consider more broadly intra-household decision-making, given some kind of interesting idiosyncratic situations in Bangladesh. So on the kind of background and framing, I think it would be a little bit more helpful for us to have some institutional background on some of these intra-household bargaining situations in Bangladesh. Bangladesh has marriage markets, matchmaking, et cetera. It would also, I think, be helpful for the reader if we were given a little bit more of a broad overview of the literature on intimate partner violence to kind of understand some of the drivers that have been found in the literature. Anything specific to Bangladesh would also be quite helpful, I think, to kind of understand potential mechanisms. A couple comments on the methodology. I wonder whether or not all of the DHS IPV questions are equally relevant in the climate context. They're certainly all relevant, but the methodology you use kind of weights them all equally. And perhaps the question, or the answer to that question is yes, if the mechanism is kind of through this, male partner stress or some sort of kind of male partner mental health channel. But if it's more of a kind of subsistence or kind of threat to food security, perhaps focusing on one or more of them that are more directly relevant to kind of a food security channel might kind of yield some insights there. From the reading of the paper, it looks like the DHS data also includes married men, so this could be an interesting source of additional information to try and pin down some of the mechanisms. And on the attribution of climate exposure, my understanding is DHS cluster geolocations are just centroids for the sample cluster. So do you have any information, perhaps like randomized geocoordinates of households, something to validate the kind of distribution or dispersion of these households to see whether or not the distance weighting of the climate data is appropriate in this setting? So the understood that the climate shock construction is very standard in the literature, but I think against the backdrop of climate change, these kind of long 20-year historical averages might bear considering a little bit more carefully. So as kind of an extreme example, let's suppose we have linearly trending either up or down. It could be temperature trending up or precipitation trending down climate data. Then more recent observations are by construction going to show these kinds of shocks. So you could kind of just look at the cluster level exposure of these kind of plot time series of the climate data and see if it kind of passes a visual stationarity test, or you could do something more rigorous with a panel stationarity test. And if it doesn't, then perhaps you could define shocks through detrended residuals or something like that. And then on the climate resilient initiatives, the descriptions that you present in the paper seem to be very, very broad, including kind of research and development funding, renewable energy programs, et cetera. And so it wasn't completely clear to me how these kind of broad initiatives might be affecting intra-household bargaining with resulting violence. So I wonder if there's a way to kind of filter these BCCT programs by different potential mechanisms through which they could be affecting IPV perceptions. I guess your take was slightly different than mine. I didn't seem to see a strong effect of the development programs, but it could be that there is some income effect through these programs that's mitigating the perceptions of violence. The other question, though, I had was whether or not the significant findings are kind of confounded or driven by selection bias. So there was very large and significant coefficients on the initiatives themselves, saying that where there are these programs, there's increased tolerance towards intimate partner violence, absent the sort of mitigating temperature shock. So it might be something to kind of look into there. And then I guess my overarching comments are this was a fantastic heterogeneity analysis. Really good job pinning down the subpopulations through which these effects are kind of manifesting as average treatment effects. But I think there could be more, there's more room to kind of push on how and why this is happening. So really nice heterogeneity of reduced form kind of relationships, but I think motivating kind of follow-up extensions, or even just kind of ex post explaining the results with some household economic theory might be helpful. And then one kind of specific comment to that, birth cohort regressions could be reflecting marriage duration rather than age. So older individuals are more likely to have been married longer than younger individuals. And so there could be some intra-household bargaining happening here that is explaining some of these cohort effects. And that's more or less all I have to say. Thank you very much. Great paper, really interesting.
Thank you, Clark, for the discussion. We maybe have 1 minute and a half for questions from the audience.
I just want to say thank you for the comments. We've taken them into consideration. Thank you.
Thank you. My name is Scholastica. I usually have reservation when like climate variable change variables are measured against dependent variable, like say rain, some drought directly on, let's say now interpartner violence, because I'm not seeing the pathway and the intuition. What does this rain do, or that? What does this drought do? What are the pathways? Later, I see a model where there's an interaction with the BCCT to bring the interventions that BCCT is doing to the households. And I kind of saw that it was reducing the violence. Maybe that intuition should come in clearly on what pathway. Because if we directly do that, it's just like putting data and then regressing at any. So there must be an intuition which is well explained in advance on what does that do. Is it reduced food so people are hungry and they are hungry and so forth? Thank you.
Thank you. That's a good question. So yes, the need for a theoretical framework and yes, I agree that maybe I should have taken more time to explain why we would expect an impact. But in the paper, we explain, for example, that it could be for an agricultural channel. So other papers have documented that already, that where there are climate shocks, there could be mechanisms leading to impact on women's well-being because of these agricultural shocks. And that one way why we didn't push further on this part is because already we have heterogeneous effects for women in agriculture-dependent communities. These effects are not, they are there, but we don't have evidence that they are statistically significant for the full sample. So economic opportunities are impacted, and the agricultural channel is at work already, and that's why we're seeing those empowerment measures being impacted. Yeah. So there's a lot more to say, but to cut short, yeah. Okay.
I'm wondering if you can tell us a little bit more about the scale of the impacts. So my understanding is right, the level of acceptance of IPV is quite high. And I'm wondering if I guess we heard that it was statistically significant. I didn't get a sense of the scale of, okay, 75% of the people say this is it's okay, to do this action. And the, whatever, an extra drought day would change that to, are we talking 74% or 50%?
Yeah, so we do have evidence that it's statistically and economically significant as well. So we compare that relative to the baseline mean for the sample that we have. So we don't see the 73% tolerance in our data set. We do have relatively high averages there for women, especially in those agriculture dependent communities. So in addition to being statistically significant, we do see that relative to those means, there is an important economic effect as well. Yeah.
Thank you very much. We are now turning to the next presentation by Clark.
Great. I think the screens up here is working now, so I'm going to try and avoid using the scratchy microphone. I'm Clark Lundberg. I'm from San Diego State University in California, and this work is joint with Ian Herzog and Yue Yu, who are both at Canadian universities. And we are studying transportation infrastructure, market access, and deforestation. Now, market access, broadly speaking, is a huge barrier to economic growth throughout the developing world. And the literature has consistently found that improvements in transportation infrastructure in particular improve market access with very large impacts on local development. However, there's kind of a small but growing literature showing that market access improvements can negatively impact the environment through direct, very clear kind of mechanical channels, but also through more subtle kind of general equilibrium indirect channels. So in this paper, we are studying the impacts of market access improvements in Uganda, looking at deforestation as a resource and environmental outcome, and we're using remote sensing data to measure land use change. We are leveraging upgrades into Uganda's national road network and an inconsequential units strategy to identify plausibly causal impacts of market access improvements. We find very significant and robust increases in deforestation when local access to major markets improves. And we find, somewhat surprisingly, evidence of a decline in agricultural activity with these market access shocks. So this is not the kind of traditional agriculture-forest tension that we see in much of the developing world. We find some associative evidence that this deforestation increase that we're documenting is driven by extraction for fuel and charcoal rather than an agricultural channel. So this work kind of broadly contributes to three major literatures, the first being the very clear study of roads in particular and deforestation. This literature has been kind of evolving slowly and seems to be quite subtle. So early evidence showed a clear increase in forest loss with roads. More recent work, Asher et al., finds a kind of more subtle mechanism. So highway upgrades in India increase deforestation, but local roads have no impact. But then there's also some evidence of decreases in deforestation as access to agricultural, more productive agricultural inputs eases extensification pressures. More broadly, this work is contributing to the large literature on market access that's studied a variety of different impacts and outcomes. And again, there's a newer literature focusing specifically on market access and the impacts that has on natural resources and the environment. Okay, so Uganda's national road network is the dominant way in which goods are moved across the country. So it carries nearly all freight cargo within the country. However, up through the late 2000s, virtually none of the roads were paved. They were almost all dirt roads. Around 2008, the national government introduced a road upgrade plan, and the sort of overarching goal was to create a multi-lane paved national road network that links major towns, cities, and other strategic locations. And this was part of a kind of long-run growth strategy called Vision 2040 that specifically targets 10 strategic cities throughout the country. And by 2019, the stock of paved roads had nearly doubled relative to the introduction of this program in 2008. So just to kind of get a sense of where and when this is happening, this is a map. In the strategic cities, we have any sub-districts, which is going to be our geographic unit of analysis, that fall within the boundaries of these strategic cities we have in yellow, and then the kind of colored red gradient are the upgraded roads with some information on when they actually are upgraded. Okay, so our idea here is that these upgraded roads improve access to markets, and we're measuring market access as a sub-county's travel time discounted sum of populations in all potential destinations. So this is the kind of Donaldson and Hornbeck market access approach. And so our actual main right-hand side variable, market access, for sub-county K, is constructed in this way. So population is the population size of a potential market destination, and we weight that by how long it takes to get from sub-county K to that market. And just to kind of show you what the long difference change in our main variable looks like. This is the market access measure in 2021 relative to 2007. And so we can see the largest changes are happening in areas where the actual roads themselves are being upgraded, as you might expect. There's also a lot of concentration and identifying variation that's coming around Kampala or other strategic targeted cities. But what is also critical for our purposes here is that we get a lot of changes outside of these direct targeted regions. And so this is the identifying variation that we're leveraging through this inconsequential unit approach. So as I mentioned, we're using remote sensing data as our primary data on deforestation and land use change. So we're using tree canopy loss data at 30-meter resolution from the Hansen et al. Data set. And just to provide a little bit of an example here to see, this is canopy cover across sub-Saharan Africa. I've got an example here that is not in Uganda. It's in Western Kenya, but it's very close to Uganda. If we focus in here, the red pixels denote loss between 2001 and 2020. We're going to focus in on this very small region here and pay particular attention to an even smaller region there. And looking at aerial imagery, we can see the type of forest loss that this data set is able to capture. I point this out because this is incredibly relevant when we're talking about smallholder producers in a setting like Uganda. We want our data to be able to reflect these types of smallholder decisions, and indeed, this data is granular enough that that it captures that. Okay, so our main specifications define loss as any kind of canopy change or canopy elimination that happens in pixels that are covered by at least 10% trees. We also include some specifications with a more stringent criteria where at least 30% of the pixel has to be covered. And we're aggregating this spatially explicit forest loss up to the sub-county level to create a panel of annual sub-county deforestation outcomes. We also introduce some additional remote sensing data. We use NDVI, Normalized Difference Vegetative Index, to measure agricultural productivity or agricultural activity. We also consider burn area extent and a new, very exciting land cover classification database that's at the 10-meter resolution. And we also include some additional survey data, the UNPS, as well as the 2002 population census. Our main empirical strategy estimates the impacts of market access here on our variety of different outcomes, focusing primarily on deforestation. We have sub-county fixed effects. We have a couple different time fixed effect specifications. We have just year fixed effects that we use, but then our more sort of stringent or demanding specifications also include region by year fixed effects. We introduced a number of control variables at the county level, interacting those with time fixed effects. We have kind of baseline county characteristics interacted with time fixed effects. And we're clustering our standard errors at the district level. Yes?
Very quick clarifying question. Does your population numerator also vary over time?
It does not. So that's based on the 2002 census. Okay, so the identifying assumptions embedded in our estimating equation are that variation in market access arising from these infrastructure upgrades is uncorrelated with unobservables driving land use change. we're leaning heavily on this identifying strategy using this inconsequential unit approach. And so what we're really leveraging is incidental increases in market access rather than targeted changes in market access. And so we're kind of further inoculated against potential road upgrade selection bias. By many specifications, we omit the actual targets, the places that were targeted by this policy. So then we are only identifying market access shocks through this incidental variation. And we also have very saturated controls, region by year fixed effects, local baseline county sub-county characteristics. And so we have ways of controlling for potential selection timing bias. Okay, so these are our main results for a number of different kind of specifications. We find very significant, I should mention too, that this is, our outcome variable here is the inverse hyperbolic sine of forest loss. And we've got log market access. So we have approximate elasticities that we're estimating here. So depending on whether or not we're including these year region fixed effects, we're finding anywhere between 6 to 12% increases in forest loss with a 1% increase in market access. These findings, once we're controlling for the more demanding region by year fixed effects, are approximate elasticities are very stable across a battery of robustness checks. So significance remains, and the coefficient magnitudes budge very little. So we weight sub-counties by population. We omit the target cities, targets being the sort of policy, the Vision 2040 policy targets. Critically, our magnitude changes very little when we omit those. We also omit sub-counties near Kampala. We then include a dummy variable for whether or not a sub-county has any amount of upgrade occurring within their borders. We then buffer 1 kilometer around the roads themselves to ensure that we're not picking up mechanical clearing when you upgrade a sort of dirt road to paved roads. We didn't want to pick up tree cover loss in the margins there. And then we also include a more stringent 30% baseline definition of tree cover. And across all of these, we have some small attenuation, but it's very small in magnitude. We also considered whether or not we were incidentally picking up access to foreign markets, to export markets, as a result of the way in which we are computing market access. So we have a couple different ways of measuring access to foreign markets. One, we just have an inverse travel time measure for how the time to the closest border crossing. That is indeed significant, but it does not take away our significant market access coefficients. We also compute an alternative market access where, rather than domestic markets, this is a similar kind of Donaldson-Hornbeck market access construction, but targeting foreign markets. And so, again, the inclusion of this foreign market access does not explain away the findings we have on domestic market access. Yes? So based on Uganda trade statistics, we constructed, I think we ended up with like 8 or so border crossings that are seeing export trade, and then calculated the same kind of travel time weighted distance to the export markets. Okay, so we have strong and robust reduced form results, but we'd like to kind of understand why it is that we're seeing these findings. And so one plausible explanation is that improved access to cash and commodity output markets for smallholder farmers might be driving incentives to convert convert forest land into agriculture. And there is some evidence that this is a relevant mechanism in sub-Saharan Africa. I have a paper forthcoming in JDE that looks at oil palm in Ghana, and we find this mechanism at play. And indeed, this has been kind of supported throughout the literature. Agriculture expansion is the dominant driver of forest loss through much of the developing world. It could also be, though, that access to output markets for forest products might be relevant as well. And so the deforestation might not be incidental. It might be a direct harvesting of a natural resource for direct sale. This is particularly relevant in Uganda, where 60% of Uganda's forest loss has been estimated to come from fuel and charcoal production. However, there's a lot of other more kind of subtle general equilibrium effects that might be relevant here. So access to urban labor markets might lead to structural transformation. There's evidence, my co-authors have found this, in Uganda using survey microdata, that there is exit from agriculture with these road upgrades. There's also been some evidence that improvements in agricultural efficiency facilitated by access to inputs might alter the value of agricultural land. It may improve productivity and reduce pressures on deforestation, or it could increase pressures. This is ex-ante ambiguous. So in all of these cases, the general equilibrium effects are going to depend on the price gradients, regional price gradients that are implied by regional comparative advantages in trade. And so I'm running out of time here. So I will very quickly show you, this is maize price dispersion across Uganda. In the market centers, here, you see relatively low maize prices, and in the kind of hinterlands, you see relatively higher prices. This pattern holds for beans as well. The inverse seems to be true for charcoal. So you see the highest charcoal prices in a lot of these major market centers, and charcoal prices are fairly low outside of these urban areas. And so what we find is decreases in our proxy for agricultural activity, NDVI, across a variety of different specifications, which is consistent with Herzog et al., the paper that I mentioned that found structural transformation happening in agriculture. So rural workers exit agriculture for paid employment in urban centers. So the UNPS data that we use to compute charcoal prices doesn't have information on production, only on prices. And so we use that to proxy areas where there's more or less production. And we find that the majority of our effects are coming from areas with low charcoal prices, which would imply areas where there's a lot of charcoal production happening. And so we think that the dominant driver, the dominant mechanism here is charcoal production. We also leverage some remote sensing data on end-line land cover in 2022. And we find that deforestation is most strongly associated with land cover that by 2022 is covered by tree canopies. So this suggests that there are some managed forestry there's some managed forestry happening here. However, I'll sort of conclude by saying that even if there is managed forestry happening, that you have deforestation, but then that the canopy recovers over time, there's still pretty strong ecological costs of forest degradation. There are also pretty serious implications regarding carbon sequestration if the forest product use is burned, right? So this is releasing carbon back into the atmosphere versus, say, managed forestry for timber or something like that, where you have the carbon remaining sequestered. And then there are also, at this kind of climate turning point, there are also non-trivial considerations regarding carbon cycle dynamics. So releasing carbon immediately, even if it eventually gets sequestered again, could have pretty big climate impacts right now. And that's all I have for you. Thank you. Oh, and I should also, I'll just mention that this is very, very early stage work. So this isn't kind of the token, please comments. We really are soliciting feedback on this. Thank you.
Hi, everyone. My name is Matt McKetty, and I'll be doing the discussion on Professor Lundberg's paper on infrastructure and market access and deforestation. And so We don't really need to do, I don't necessarily need to go through the re-summary, but basically, they're looking at the impacts of these road improvements within the context of Uganda and seeing, the spatial impacts on forest degradation, and then also breaking down those effects. What I thought was really neat was breaking down those effects or the causes of this deforestation into whether or not it's agricultural production or increased agricultural production or non-agricultural activities. So I thought it was also just in terms of general comments, like a really effective use in terms of an identifying event, the plausible exogenous change with the national road network expansion in Uganda, and it gave some really good, nice spatial identification, and then also the variation in cause of deforestation. Really neat and effective use of remotely sensed data on. In terms of satellite imagery, spatial resolution, and spatial resolutions to measure these changes. Remotely sensed vegetation data has been used pretty widely elsewhere in the world, but it's only now very recently expanding into sub-Saharan Africa, and so this is really cool to see that used. And then also good background on within the paper and in the presentation of the political or the kind of the political context and geographic context for Uganda. This was probably less relevant for the presentation, but within the paper, just additional motivations of the ecological significance of deforestation would be important or would be helpful, even though in and of itself it's deforestation is problematic. And further discussion of that could be useful. It may be also helpful to employ other vegetation indices in as robustness checks. Different ones emphasize different aspects of plant health, and so that could be useful as well as a robustness check. And then for the third point, wasn't. I don't think this was covered in the presentation, but in the paper, there was this mention that about a 30% cutoff in terms of, I believe, of tree canopy cover was used at some point. Was used in additional motivation for that would be good, just since someone wasn't necessarily familiar with. I didn't necessarily understand that immediately, so that could have been helpful. And then also, additional household data, if there is any from the period being linked with your findings, could be see how households could react in terms of their own activities could be useful. But overall, really very interesting and important and a really effective combination of techniques. And that's everything I have.
Thank you. We have a few minutes for more questions.
Hi, nice presentation. Thank you. On the question of native forests versus planted forests, wouldn't it be possible to maybe look at planting and harvest cycles over a period? Because if they are cutting trees for charcoal production, it's probably exogenous species such as eucalyptus, which have a shorter clear-cutting rotation period.
Hello. Yes. Thank you. That's a great point. I didn't mention that the deforestation data that we're using does not have regrowth measured. So the idea is that when you're using this very granular criteria for loss, that's fairly easy to identify. Planting and regrowth is much harder to identify given the these kind of long dynamics. And so we don't have data on that. We are starting to try and work with a different measure of deforestation as kind of a robustness check that is just a kind of continuous canopy rather than this loss measure. But yeah, I think there are kind of spatial cross-sectional data sets on primary versus secondary forests that we might be able to leverage a little bit more. Unfortunately, we can't identify species. There's not a good data set because that requires kind of on-the-ground forestry surveys that we that wouldn't be available here. But I think with primary versus secondary, that might be something that we could actually include in our analysis. Yeah.
Thank you. I find it hard to believe that these new roads don't very fundamentally change the population distribution. And thereby, by using this 2002 population figure, I would imagine that would not inform too much on market access in 2018 or whenever is the final periods of your study area. And I can see ways in which that effect would operate in a direction that would that would cause bias in your results towards the results that you find. Thank you.
Could I ask you to elaborate on that last point? Because my initial knee jerk would be that it would be the opposite.
I can see it in both ways. So, for example, if we're connecting certain areas that weren't connected before to major cities, that could create outward migration from those areas to the cities, therefore making the population smaller, which would therefore create positive bias in your results, or the other direction too.
Yeah, I think we could. I think there is a more recent census, so we could check. Yeah, that we could check whether or not there's evidence of that. I guess in my mind, migration frictions and interregional trade frictions are very different in magnitude. So I can't imagine if you're going to migrate to the sort of rural countryside, having to do so along a dirt road is not going to be a salient barrier. Whereas if you're trying to get your products to sell somewhere, then having to go through kind of a muddy dirt road may matter. But all that to say, this is an entirely plausible mechanism that we can at least look at.
I won't linger on it, but it's not just about the initial decision to migrate, but whether it's worthwhile to migrate. And once the road is there, the fact that it's worthwhile to migrate, you can go back home to your family much easier. You might have other business opportunities. So it's not just about that initial migration decision.
Great, thank you.
So I just want to encourage you to really think hard about this difference between deforestation and cutting trees that you're planning on regrowing. And I think those are two completely different equilibrium, and your story is completely different if what's going on is, oh, okay, so there's a road here, so maybe I migrate, and I sell off the trees on my land and replant them, and every 5 years I'm going to cut eucalyptus, and that's how I make money. So that's in some ways an agricultural outcome, right? Particularly if they're doing some fast-growing trees like eucalyptus, which that seems to be the story in a lot of Ethiopia, where you have people leaving their land, replanting in fast-growing trees for charcoal or construction production. And I realize that the carbon effect is maybe similar, but I think the kind of development effect those are two very different outcomes.
I guess my only response is nice point. Yeah, I mean, I think I agree. I think to your kind of final point, I think the environmental implications still matter for this particular type of managed forestry. As I mentioned, if you have timber, for example, the carbon is still sequestered when it's used as a building material. When you're creating charcoal for burning, it is not. And so the dynamics might be slightly different than just mowing down native forest and then burning it and then planting crops, but the atmospheric carbon implications are really the same. Yeah. So I guess I think that's an interesting point that we can try and dig into a little bit more with the microdata, the survey microdata, but unfortunately the modules don't have a ton of detail on charcoal production activity relative to agriculture. So it's a bit tricky, but I think we can try a little bit better.
Alrighty, good morning, and thank you for coming to the presentation. So I'm presenting work on agriculture, climate change, and household welfare in Mali. That is joint with my advisor, Jeremy Foltz. I'm a grad student at the University of Wisconsin-Madison. And we can go ahead and get started. So it's pretty well established in the literature that climate change produces changes in agricultural productivity. But what is less well understood is the extent to which these changes in productivity will produce changes in household household welfare. Putting down a timer, and then. And so one could imagine scenarios in which the effects are closer to 1-to-1. 10% decrease in agricultural productivity produces a 10% decrease in agricultural welfare or in household welfare for farming households. But also households do display resilience, do varying activities, and that relationship might be much more complex. And so that's part of the motivation for investigating this. But another issue that is present is that in many developing countries, and particularly much of sub-Saharan Africa, use of remote sensing data that can or use of on-the-ground measures of agricultural production are oftentimes lacking, whether because of just lack of capacity, also lack of or also smallholder farmers and irregular plot sizes, that kinds of things. And so remotely sensed vegetation indices taken from satellite imagery can serve as proxies for those in cases where in-field measures are not present. And so we attempt to then fill that gap. So the first question being, can we use vegetation indices as proxies for yields? If so, which ones? And then the next being, do increases in agricultural productivity increase household welfare for rural Malian households? And if so, by how much? So this paper contributes to a few areas of the literature. The first on the relationship between anthropogenic climate change and agricultural productivity, but also the literature is on the relationship between agricultural productivity and household welfare or well-being. And then also the literature studying the relationship between climate resilience to climate change or shocks to productivity and that kind of thing. And so, as a quick introduction to vegetation indices, because we have time constraints. So, vegetation index is a spectral imaging transformation, usually composed of at least 2 image bands. And so it's designed to they're designed to capture the degree of photosynthetic activity or in the health of plants or various types of or crops. So a number of vegetation indices are typically used. The most common being the normal difference vegetation index, but there's also the enhanced the EVI, and then the GNDVI, and then the one that we will go into further and that we use primarily in our study, the green chlorophyll vegetation index. So this is a map comparing vegetation indices. So Mali, this is a map of Mali. You can see these are pretty well correlated. The agricultural lands in Mali are mostly located in the south, and NDVI in particular is usually described as a measure of greenness and measuring the photosynthetic health of plants, and so that you can kind of see that gradient as we progress into the desert, and we see GCVI and NDVI compared there. So GCVI specifically measures the level of leaf chlorophyll content in plants and uses reflectance in the green wavelengths, and whereas NDVI measures the level of photosynthetically active biomass and uses reflection in red wavelengths. GCVI has been shown to be more responsive to changes in leaf chlorophyll content, which is particularly important for plant health. And this has been shown in a study of smallholder farmers by Burke and Lobel in Western Kenya. GCVI outperformed NDVI. And so following Burke and Lobel, our preferred index is GCVI, though we use as a robustness check, we also employ NDVI. So as an initial just kind of sanity check, we obtain LSMS yield data from Mali to do that kind of initials, looking at the relationship between NDVI or between NDVI or this major vegetation index and yields, finding a strong parabolic relationship between the two. We use like the log yields of the major grains, maize, millet, and sorghum, and the NDVI was geolocated within the LSMS data, which is why in this case we use it. But then moving forward for our when we use, in terms of using a vegetation index as our proxy, we use GCVI. Okay. So our main empirical specification is the following, where we have, as our outcome being the per capita expenditure for households in a commune in a particular in a particular commune during a particular half year. We divide our data into we have the data for household expenditures at the quarterly level, but then we aggregate that up to the first and second half of the year. So when I refer to half year, that's what that will be referring to. We then take within commune mean of GCVI during the within an agricultural season, and then we also include half year, year, and household fixed effects, and then we cluster our standard errors at the commune level. In terms of data, we use the Malian enquête modulaire and permanent prix des ménages, or EMOP data set. So a regular household survey. We had it for the years 2011, 2013 to 2016, and 2018 to 2019. Asking households a variety of questions regarding expenditures on food, non-food items, and then also broken down into auto consumption, purchase consumption, and consumption that comes from gifted items. We have data covering most of Mali's 704 communes, so about 596 of them. For our measures for our vegetation indices, we get from Google Earth Engine using the Landsat system for GCVI at a 30-meter resolution, and then for NDVI, and we obtain that from the MODIS system, that comes at a 250-meter resolution. And then we go into details of how this is specifically calculated for the maximum, but we can go into that I can go more into that in details in questioning or during questions, but we're going to keep moving just for time. And so as just summary statistics of the value of for our data set across expenditures. So we have per capita expenditure measured in CFA francs for a particular half year for each of these households. Broken down by we are able to disaggregate our sample by rural and urban, and so we will be understanding these effects or disaggregating our effects also by household type, and we will primarily be focusing on rural households. So as initial results, so for the relationship between GCVI and just overall consumption expenditure, we see initial for the log specification an elasticity about 0.1 between changes in GCVI and changes in total household expenditure, with this being primarily driven by increases in non-food expenditure. So that a 10% change in GCVI produces about, produces a roughly 1% change in total expenditure for rural households, and I'm continuing, and with this effect decreasing, with increases with the extent of this increase decreasing with increases in GCVI, and so. And so then moving forward, because even though for our major consumption categories we have data for the vast majority of households in the sample, as we get more granular, there's some there are some zeros for things like particularly non-consumption items. So we switched to using the inverse hyperbolic sine transformation for those. But just as an initial proof of concept, we have nearly the same coefficients when we use the IHS approach instead, and so we can still continue to still consider it as being an elasticity moving forward. And so when we break down our results for rural households into across consumption categories, we generally see increases in consumption of grains, and then also increases in consumptions of like luxury type, we consider like luxury items like meats as well. And we continue to have the same kind of parabolic shape for consumption that tracks from the overall from the initial general consumption results, and then also from our regression of the vegetation indices on yields. And we also then disaggregate down into the value of own produced items and gifted items as well. So when we disaggregate a bit further, we see that these increases for grains are primarily being driven by increases in purchase consumption, and then increases in gifts that are received from outside the home, with a big decrease in consumption of or expenditure or the expenditure value of like own produced food or own produced grain items. We also see that for rice, which was initially insignificant, that there is actually a significant amount of movement within that consumption category, with similar increases in consumption of from outside the home, either from gifts or from those that are purchased. Then we moving into non-food consumption, which is where we see the much larger magnitude of an increase in spending, though still much less than the one-to-one expectation that the one-to-one result that you might expect if there was this lack of any type of resilience. We see that we see shifts towards more luxury items type purchases, like that being like increases in clothing, and then also like a general category that we didn't include here, just like just other consumption, but with a lot of that being driven by increases in clothing, and then other types of items being sometimes with some changes in like on the square terms for say health consumption, but other than that, these being insignificant. And so then, as a comparison, we look at the results for urban households, generally finding that there is the same basic trend, but with far lower magnitudes and the significance levels a bit more marginal in term but the same basic pathways continues, but for with non-food expenditure being the stronger results. But as we would expect, because since urban households are generally expected to be less impacted by agricultural changes in agricultural productivity in terms of their own expenditure, or less directly impacted, we see the magnitudes being far lower than for rural households. And then we conducted a number of robustness checks. So the first is then using NDVI. We also then tested first, using the LSMS data to see the relationship between these vegetation indices, fixed effects that we use, and then also looking at seeing how the results varied across households. Once again, for time, we'll just look at only the one of these robustness checks in terms of. Oops. Okay. Let's go. Oops. Okay. Going here. When we regress with NDVI, the results are even stronger, and further support the patterns that we were observing for overall expenditure. Although we prefer GCVI both because of the added granularity, the ability, and the 30 meter. The 30 meter level of granularity, and also perhaps being better able to measure different types of crops that has been suggested in the literature. But when we regress on NDVI, we also get the same essential pattern. And then for our to conclude, so we've demonstrated that it's possible to use remotely sensed vegetation indices as proxies within the Malian setting. And then also to extend this usage extend the usage of these indices to understanding changes in household consumption and household welfare. and we then see when we extend these, when we then employ these as proxies, we see that households display a striking amount of resilience in the face of changes during the period of our study, and so what these suggest is that suggests that at least for some portions of the population, of the rural population, there is a degree of adjustment, and so it requires additional research into understanding the effects of climatic changes on household welfare and to what extent households are able to adjust to changes in agricultural productivity. But this is an initial start towards that, and that's everything.
Thank you very much for your presentation, Matthew. So I had a few comments. First, I think the paper is very interesting because we focus on the demand side of climate shocks, and this is something that is not very well documented, and I think on that matter it's really interesting. Also, the use of a variety of measures, but in particular the rich information on the nature of consumptions, I think is also something that is nice about the paper, and also how, obviously here for the sake of the presentation, you couldn't show everything, but the decomposition within the non-agricultural consumption and the effects on these non-agricultural consumptions are very nice in the paper. And so I had three main comments about how the analysis is written. The first one is about the identification and how well do you capture actually climate shocks, which is the main motivation of the paper. I wonder if with those GDVI measures, you don't capture only like short-term fluctuations in weather conditions, reflected by a greenness index. And if that would be worth maybe to try to, as a suggestion, to perhaps improve the current version of the paper, is to look at long-term trends in the data and maybe following the long differences approach that has been developed by, for example, by authors like Melissa Dell and co-authors. That would be one first suggestion, so trying to capture a more long-term effect rather than seasonal effect. My second comment was about the specification. It is not clear to me what is the motivation for the non-linearities in the effect of yield. And we see that very well in your results is at some point, yield seems to become a negative for the amount of consumption of any kind of consumption. And intuitively, I wouldn't think that too much yields would actually be negative for consumption. And I was wondering also in the specification whether it might be subject to omitted variable bias, whether that would be possible maybe to control for other factors such as the initial level of incomes. But I don't know if the IMOP data can allow this, or maybe some sort of variations in international price of the main products and agricultural products, like weighted by the distance to a port or something like this. About the results, and that's the last part of my comments. I was actually, so on the non-linearities, I was wondering if it's possible that the subsequent negative effect that we see in the increase on yields on consumption wouldn't actually be some form of investment. So some behavior of savings, or say buying a cattle, postponing consumption to accumulate some form of capital that you would see in the data, and perhaps the paper could gain from looking at this possibility. And in the end, with the nice elasticities that are estimated for the different consumption variables that you have in the paper, maybe it would be interesting to have some sort of a projection exercise with given different climates and projected changes in yields. What would be a consumption? What would be a consumption at some given time horizon, for instance? Then I had a few comments on the manuscript itself, but that's something I can share, send it to you maybe later. So that's mostly about it. Oh, and I should say that now we have time for some questions from the audience. Complete. Yeah, we have one question.
Thank you. I like the paper. I like the motivation, climate change, yields, welfare. But overall, I was asking myself, isn't the overall climate change in fact that you have a negative GCVI, so a reduction in greenness, and this kind of gets a bit lost because when you present your result, it's all about a positive increase. And so we, in our heads, maybe others in the room can do that, but I can't do that so quickly. Thinking about that, actually everything that you're showing us, I need to put a minus to it. I think, and I don't know, it's just a conjecture that greenness declines over time. So I think if you want to really make that link, climate change, yields, and then yields to welfare, it would be great to do the first connection as well a little bit. And this is purely motivational, purely descriptive, over time, what's happening in Mali. And then if I may, a second point, it's clearly a hugely diverse country in terms of agriculture and vegetation, not just north-south, but I guess also east-west. So if you could play around with that heterogeneity a little bit, do separate results for different types of regions also, that'd be great. Thanks.
Thanks. As somebody who uses remote sensing data a lot, this seems very exciting. So I guess, do you have any of the household survey microdata? Does that collect information on prices or income at all? Or is it purely expenditures?
For prices, no. For income, I don't believe, it's not, if there's anything, it's not like trustable, or like, or not, verified, so we don't use that. But for prices, it's only at the at a more aggregate district level.
Yeah, this strikes me as, if maybe in a different setting where you might have better expenditure and or price data, that this could, for rural economies, perhaps be an alternative proxy for, like income growth rather than just like the night lights that everyone uses, especially in areas that aren't very electrified to begin with. So I think it's quite a promising approach.
Thank you.
Okay, so if there is no further question, we'll now move to the last presentation of this session. So this is, I am Julien Wolfersberger, and this is a paper co-written with Doug Gorlin, and it's actually very close to, in terms of thematic, to what Clark's paper that he just presented before. So we are looking at the role of new roads in the process of agricultural trade and the impact on deforestation. So to introduce the topic, actually, my introduction slide looks a lot like the one of Clark, because I was going to say that as economists, we know that roads are very important, and they are very important because within trade frictions actually distort the resource allocations and can affect economic development outcomes in many ways. And it also has an impact on the variation of land use change, because, and possibly at the expense of the environment, because it opens access to remote areas and creates in or out migrations of workers, capital flows, economic activity in general. In this paper, we basically ask how do new roads have impacted deforestation in Brazil since 1990, and we are going to look at that in different ways. So a bit of context. Brazil is among the countries with the largest total amount of forest cleared each year, and obviously it's an important environmental issue because it causes greenhouse gas emissions, biodiversity loss, and threatens local communities. And the main cause of worldwide of agricultural land expansion, and including in Brazil, and this is where maybe the setting differs a bit from the case of Uganda. So it's definitely agricultural land expansion, and in Brazil, exports of agricultural commodities is a key component of the development policy. For example, in 2023, the country reached its highest record amount of agricultural export with over $160 billion of exports in agriculture. And soybeans, soya represents almost half of this export pattern. What we are doing in this paper is that we are trying to quantify the impact of roads, both on deforestation and some development outcomes. Basically, we ask how much total forest loss can be explained by new roads since the 90s, and what are the economic costs and benefits of those new roads. Our goal, using a general equilibrium effect, general equilibrium model of trade, we are trying to disentangle how price diffusion in space affect specialization patterns across the regions, the Brazilian regions, and how it does affect forest. And we try to pay attention to the heterogeneous impacts of those specialization patterns across space. So, as I was saying, our methodology is based on a quantitative spatial model that we take to census Brazilian data and satellite data on forest cover and road locations. And our main findings is that we find that comparing to what's happening in the model and what's happening in the data, we find that since 1995, up to 22% of the total forest cover lost can be explained by those new roads that were built over that period. The thing is, we find that the increase in the agricultural income was relatively limited compared to the environmental cost of those new roads. Just to give an idea of this cost and of a one-shot cost that would be evaluated with the carbon price, that is the US government the carbon price of $51 per ton, we find that it represents, for example, almost 150 billions of dollars, those forests that are gone because of the new roads. So, and again, I feel like I have the same slides as Clark, but our primary contribution, the literature we are contributing to first is that literature on environmental and development econ that has been looking at the impact of roads on deforestation. Those methods are mostly empirical reduced form analysis, and really what we are trying to bring here is the fact that we take into account the general equilibrium effects of those new roads. And this is potentially important because it's likely that such a huge infrastructure change like new roads are going to create changes in specialization across locations and across sectors simultaneously in many locations, including in locations that are not treated, that are not traversed by new roads. And so we are trying to argue basically that this is why it is important to use this kind of method. Other papers have used those methods applied to agriculture and forest, and we really look at what's happening within a country in the historical context of Brazil as a contribution. And we also talked to literature on the policy accompaniments to halt deforestation in Brazil. And here, what we are trying to say is that where roads are being built actually matters a lot. So I will present briefly the 4 motivations that guide the design of our model. 4 very simple empirical motivations that will justify the choices that we made to build our quantitative spatial model. First one is that obviously road proximity varies through the country, and that means that market access can be very heterogeneous from one region to the other. That's for 1. For 2 is that market access is actually positively correlated to forest clearing. Here it's a simple OLS regression that shows a correlation between the distance to the mesoregion's centroid distance to the largest international port. And what we can see is that the further away the centroid of the mesoregion is, the more share of land under forest is left in that region. So differences in market access positively related to forest clearing. And the facts 3rd and 4th are that obviously land productivity varies across space, and some regions are going to be more productive at producing certain crops than others. And that matters because of fact 4th, which is that depending on the crops that a region is going to specialize its production is, the pressure on forests is also going to vary. Obviously, to produce 1 ton of soybeans takes much more land than 1 ton of coffee, for example. And so this is what we are trying also to capture in that model. So based on those 4 simple motivations, we proposed the following model. We built the following model. So our framework is such that we have multiple locations that we will take to the data as corresponding to Brazilian mesoregions. Each location has a continuum of plots and can grow several crops over each of those plots. The thing is to open the land for agricultural use, farmers have to pay a fixed conversion cost that corresponds to some sort of investment in land clearing. This is the cost A0. We have 1 trade hub that encompasses the 10 largest exporting ports in Brazil, and consumers are located at the trade hub. Both domestic and international demand is at the trade hub, and agricultural producers, are located in the mesoregions, producing basically the crops. Those producers face iceberg cost to ship output towards the trade hub, but they also face that same iceberg cost to import modern intermediate input for agricultural production. Agricultural output at the plot level looks like equation 1. So in a region I, to produce a crop K in a plot omega, this is a combination of labor N, intermediate input H, and land L. And the land is subject to a productivity shifter A that is going to capture the difference in the land productivity for different crops in same given regions and across plots. And as standards in that literature, we assume that those productivity shifters are randomly distributed from a nested Fréchet distribution here. And we have an outside sector that simply combines the labor and a productivity level to obtain a level of output, a given level of output. Consumers spend a constant share of income on agricultural bundle, on a bundle of agricultural goods. So they value those different crops given an elasticity of substitution between those crops that is given by sigma. The rest of the income is spent on the outside good. We view the outside good as a mix of as encompassing manufacturing and service activities. Our competitive equilibrium defines the prices at the trade hub within the mesoregions, wage as well as prices for the imported intermediate inputs. We have labor demand and in both sectors also, imports and exports, and market clears for labor, land, and both goods, cake crops and the outside good. To give you a hint of maybe a more precise image of how the model works, basically one result of the model is that the share of land that is going to be allocated to any crop K is going to be the product of two shares. The first share is the land share that is under agriculture in a region I. This is PAI. PAI is the ratio of that capital fee. Capital fee, this is the sum of all the crops of a term that is Z is the land productivity for crop K in region I, and Psi is price index, basically. And so that capital fee defines the profitability of agriculture in a region I, and the land share under agriculture is going to be the value of that profitability relative to all the other use, so that is agriculture itself, plus the value of the investment, P0 times Z0, the value of the investment that is required to open the land for agriculture. Within that agricultural land, a crop K will be the size of a crop K will be defined by equation 4. This is basically the relative profitability of K relative to all the other crops in that region. And our elasticities theta 1 and theta 2 are going to govern the land supply response to changes in prices. Theta 1 is going to govern the land supply response between forest and agriculture in general. And theta 2 is going to govern the response between crops supply response. And just before jumping to the results, focusing on the numerator of equation 3, this is exactly this expression. And to give you a hint of how the model is working is that, so Z is still a productivity parameter, but then we have this price index. This price index is PIK, this is the farm gate price. Then we have the wage, and we have the cost gate of the intermediate input. What's happening when transport costs go down is that the farm gate price will go up because the iceberg cost went down. And I should have precised that PK is the world price of the crop K. So the farm gate price will go up, and the cost of importing, so the price of the intermediate input will go down. And so that immediately makes agriculture through capital fee relatively more profitable than the clearing investment P0, Z0. And this is some little intuitions of how the model is working, but then with general equilibrium readjustments, it's not obvious that every regions are going to increase their agricultural land use. Okay, we calibrate the model to the Brazilian mesoregions on the 2017 agricultural census from the national statistic data. And we use the potential yields from the FAO GIZ project. And we estimate our trade cost elasticities to get a measure of our tow. And we combine this with parameters from the literature, basically. To have our estimates of the transport cost estimation, we exploit price difference in space to infer those transport costs. So it's basically following what Donaldson or Sotelos have been doing in that literature previously, is that we are going to assume that the difference of the soybean price at the port and inside the mesoregions are going to be a function of the distance. And we get an estimate that is of beta 1 that is around 0.2, which is in the range of the literature. We take all these other parameters from recent papers on the topic, and we obtain a model fit for the land that looks like this at the moment. So this is for land uses. And for output at the moment, it's less clear that it's looking like that. And so, looking at counterfactuals now, what are the counterfactuals that we are running? We are looking at what would be the spatial equilibrium of the economy absent of road construction since the 90s. So basically, we ask how much more or less forest shall we have if the investments in the road infrastructure didn't happen since the 90s. Also, within that, we try to see what's the role of input adoption in the process of deforestation through the decrease of transport cost. And this is why we consider a case where the change in TAUs actually affect only output and not inputs. Overall, we find the following results. Forest cover would be, according to our model predictions, would be almost 2% higher than what it was in 2017 if the road hadn't been built since the 90s. And so that represents a little more than a fifth of the total deforestation that was observed over that period in Brazil. The increase in gross agricultural income would actually be lower by 1.8%, and agricultural exports would also have dropped by, say, something like 12.6%, according to the results of the model. Also, we can see that in that gross agricultural income result, it's actually what the model seems to suggest is that it's actually the first quartile of income distribution across mesoregions that has benefited the most from the road constructions, because absence of these road constructions, income in those municipalities, in those regions, would be 5% lower than what it is today. When we compare the situation on forest losses to what would happen if it was still, we take away the old roads, but it's still that easy to import international intermediary inputs within the mesoregion. So that put it differently, we apply the counterfactual only to output. We find that in this case, the gain in forest cover would be only by 1.2% higher than the total forest cover that was in the country in 2017, meaning that we interpret those 0.7 percentage point difference as the supplementary amount of deforestation induced by the more easy way to import intermediate input and to modernize agriculture somehow. Before concluding, because I'm running a bit late, if we disaggregate across mesoregions the result, we can see that the model is doing a pretty good job at capturing what's happening relative to the data. in the sense that we have this sort of, so land use change is actually the agricultural land expansion percentage. And so the more a region has been impacted by an increase in trade cost, in transport cost, because remember, we take away the roads that exist, the more the forest is gaining. Obviously, there is a lot of heterogeneity that we see in the data that we cannot capture with the model because a lot of other things are happening and explaining the forest clearing in the country. And so the last slide on the results, just to show the heterogeneity across regions. Maybe I'll focus on that that region here, center east of the country. That is the state of Mato Grosso. That is the state that has experienced the largest amount of deforestation since the 90s. We see that according to the model, actually forest cover would be in some of those mesoregions 50% higher than what it was in 2017 had the roads not being built towards those regions. But agricultural income would be 50% lower too in those regions. So that highlights how much forest clearing has been impacted across space and heterogeneously across space because of the new roads. So to conclude, we find that new roads contributed to more than a fifth of total deforestation in Brazil since the 90s, according to the quantification of our model. And that explains even up to 90% of what we see in the data in a state, in some mesoregions of a state like Mato Grosso, which was a hotspot of deforestation over the last 30 years. One message from this work is that road alters incentives in the place they traverse, but also elsewhere, and the reallocation of production across space because of new roads and the general equilibrium effects that are generated by this reallocation can be important to understand how transportation costs affect forest clearing. And all in all, it is hoped that this work highlights the fact that we need to think carefully about the impacts of transportation infrastructures, particularly relative to their cost, which can be quite high. The carbon cost I mentioned earlier in my introduction is only a one-time evaluation of how much the roads have cost in terms of carbon price. It's a one-time evaluation with a $50 value for the ton of CO2, and it ignores a lot of things such as biodiversity losses or threats on local communities and displacements of local communities. So the cost of actually building new roads can be much higher than what we think, and the impact of the environment can be quite huge. That is it. Thank you very much.
Okay, so thank you, Julien. I really appreciated reading the paper. It's an excellent paper, I must say. It's very intense, whether theoretically or empirically. Let me just, I'm not going to summarize again because I think an excellent job has been done already, but I just want to highlight the important contribution of this paper. So as you have seen, it's investigating the expansion of Brazil's road network on agricultural production, deforestation, and development. They have a quantitative spatial general equilibrium model that's calibrated and taken to the data. And I think that's an important advantage compared to the existing literature because they are able to account for the diffuse spillovers from road networks. They have a comprehensive array of data sets. He mentions a couple of them today, but I think there is a lot going on in the paper. There's agricultural censuses, high-resolution satellite imagery. And so this also highlights the study highlights the importance of spatial heterogeneity, how regional variations actually can allow us for a deeper understanding of the impact of local conditions and crop-specific factors. And there are, of course, important implications for policy formulation for the use of free counterfactual analysis on past and future transport costs. They are here providing evidence-based recommendations to achieve development growth with lower ecological cost as well. So what I would provide here is just two suggestions. I wish they could help Clark as well, but they are mostly related to trying to match the ground truth realities in Brazil and some knowledge of what's happening about these other policies that could be impacting deforestation and development. This was an era of labor augmenting and land augmenting technical change in Brazil. And I'm here thinking of one paper that I studied when I had to write my own job market paper a couple of years ago by Paula Bustos and co-authors in 2016, which is an AER paper showing how the adoption of genetically engineered soil and the introduction of a second maize season significantly altered labor requirements, land use intensity, and agricultural productivity. So these changes were happening, not exactly at the same time, but I would say concomitantly, related to your study period. So factor intensity, land intensity, these are also related to land clearing patterns. They also affect the reallocation of labor across sectors. So while road expansion facilitates market access and therefore could initially encourage deforestation, these technological advances, at least documented by this 2016 paper and by other studies in the related literature, could alter labor and land use efficiencies. So these technologies could either offset or complement the environmental effects. So I'm convinced that some of these features are already embedded in their theoretical framework, in the calibrated parameters, in the general equilibrium model. But I think just a quick discussion of how these land augmenting and labor augmenting technical changes happening, in the 1990s in Brazil could somehow either provide scope for further research, extensions as well based on your study. And then the institutional environment in Brazil, we know that the country has a history of insecure and ineffective property rights, deeply rooted in imperial times. So this could hamper agricultural productivity, exacerbate deforestation, because it discourages long-term investment in sustainable land use and conservation. And there is already, empirical evidence on the detrimental impact of property rights insecurity and political instability, and also poor governance on deforestation. So this is somehow underscoring the role of institutional weakness in fostering environmental degradation. So again, I think just a quick discussion somewhere in the paper on how this variation in the institutional framework in property rights security and institutional quality could mitigate deforestation rates, and that could actually provide a counterbalance to the pressures exerted by road construction and agricultural expansion. And I was just thinking to conclude here, if there is a need for extensions or to try to proxy for these institutional changes, we have been seeing the use of mesoregions in the paper. So these are subdivisions of Brazilian states that group together municipalities. I think the translation would be districts, municipios based on geographical proximity. But there is also disaggregated data at the municipality level, right? So a municipio in that case would be a more granular administrative division within states that's actually serving as a distinct administrative and political entity. So they have these districts or these municipals, they have much administrative freedom. They have the ability to allocate spending, to levy certain taxes, and to enact their own legislation. So this means that there is actually variation as well in the institutional forces at work at a more disaggregated level, because the mesoregion is quite aggregated, but I understand also the need based on the model that they have to use mesoregions. But if ever you're thinking of extensions, just know that there is rich data at the municipality level that's providing an opportunity for potential extensions by leveraging the more detailed governance and administrative nuances. But other than that, excellent paper. Congratulations.
I'm wondering about your choice of soy as the main crop, and I don't know how consequential this is, but my understanding is that it's cattle ranching that is the forefront of the deforestation, and the land goes into pasture, and then it subsequently becomes soy. So I guess I'm wondering about that choice and whether it's consequential to your modeling.
No, that's a very good question. Actually, I realized I didn't make this clear in my presentation, but we have 9 crops. So it's not only soy, and we have pasture on top of this. So yeah, this is completely right. It's because it's at the frontier. It's mostly for pasture that deforestation is happening, and we do have cattle in the model. So yeah, and yeah.
I really like the point you made about new infrastructure leading to a change in specialization patterns in the beginning. And if I understood a bit of the model correctly, and I thought you tried to reflect it in the prices, but it would have been nice to see empirically, and I think you can do it at least maybe with the 9 crops, that you show dynamically over time with new roads opening that there is actually this change in the composition of crops.
So, yeah, you mean measuring, so historically since the 90s, how the specialization of observing in the data, how specialization across the regions has been changing?
Yeah.
Yeah, that would be nice. Yeah, no, definitely. And that could improve the motivation part, I think, for the, yeah. No, that's a great surprise.
So are the conversion costs only incurred going from forest into a crop? So meaning there's no land use dynamics. It's just forest or a particular crop. Is that correct?
Yes.
So it might be interesting. Got the R&R, so don't do this now. But like it might be interesting though to consider some of these transition dynamics. It's incredibly salient in the Amazon when you have conversion into pasture. Then the subsequent conversion costs are very low. And I guess this is more broadly related to the idea that you could have like commodity-specific conversion costs that are kind of related to some of the technology points earlier. So not all crops are equally suited for every piece of land standing under forest in Brazil.
Yeah,
so some.
And it is true that we are missing this kind of facts at the moment in the model. Yeah, no, that's true. Thank you. Okay, so thank you everyone for attending to this session.